Well, good morning, ladies and gentlemen, and welcome to this online session. We're going to talk about the largest CSP project to date, and it's one that is like very close to my heart because, as you know, concentrated solar power, what it does is it collects the sun's heat, and it can actually store it for a very long period. And in the case of DEWA 700, we have 15 hours of storage, and it is then dispatched when it's needed. So we're going to hear more about this mammoth project and how it's coming along. It is still going to take a few months, before it comes online. And of course, we do have to bear in mind one thing, and that no one was expecting, and is this whole COVID crisis that I am sure, is going to be harder in terms of the project updates and how much information we have, because as we know, the whole world has come to a standstill, but we're going to see where this project is at today. So I'd like to welcome everyone, and I'd like to introduce you to the two experts that are going to be speaking today. And I'd like to introduce yourselves, Miriam and Manuel. So Miriam first, if you can unmute your microphone and introduce yourself and your company.
Hello, everyone. Hello, Belan. Thank you for the invitation. It's an honor for us also to participate in this webinar. So my name is Miriam Belizim. I am with Aqua Power for almost 8 years now as part of business development team. I have led the development of the DEWA CSP PV hybrid project, and I would be happy to answer questions today.
Thank you very much. Miriam has already said something very interesting. We are going to be talking about hybrid technology approach. But Miriam, where are you based today?
So I'm based at home.
Which is in Dubai, right?
Yes, I'm based in Dubai. But here also we started the lockdown. Yes, so I'm at home.
Yeah, okay. This is one of the advice I'm going to give everyone. Stay home. It's really
yes,
Spanish
definitely.
experience. Yeah. All right, Manuel, could you please introduce yourself and your company a little bit?
Hello, good morning or good afternoon, everybody. This is Manuel Martin. I'm located in Seville right now, hiding at home, like most of you, I suppose. I've been working in Abengoa for 13 years, more or less, always in the solar technology department. Right now, I'm the solar field engineering manager for the DEWA project. I appreciate your invitation, and it will be a pleasure to share with you about this project.
Excellent. Thank you very much. Okay, so this is the way this panel is going to go. Miriam is going to speak first, give a presentation, then Manuel, and then we'll take some questions as well. And I'd just like to welcome everyone. I see there are people from Lebanon, from Egypt, from Tunis, from everywhere, France, Germany, Netherlands, UK, Spain. So welcome everyone. Stay at home. I hope that you're working from home. As you know, this is not probably like the right time to be out there. I hope you are all keeping safe. All right, Miriam, why don't you share your presentation, make sure you unmute your mic. And whilst Miriam does that, just like to remind you, a lot of you already know our webinars very well and have been here before. But for those who haven't, it's very simple. Miriam is going to speak, then Manuel, then we have the questions. You can send the questions through the Q&A box at the bottom. In your bottom, we use the chat just to introduce yourself, and we use the Q&A to attend to the questions thereafter. We are recording this session, so you don't have to worry. You'll get the slides, and you will also have the ability to see the entire presentation and watch the whole thing again. So Miriam, you're ready?
Yes.
Okay, we can see this perfectly, so go for it.
Okay. Perfect. So yeah, I think it's important to still talk about a hybrid project. So last year, I think it's again, I think it's around a year ago, we had a webinar also about hybrid project, and in that case it was PV and CSP, where the project at that time was still under development. It was not yet financially closed, and last year we discussed more about how we reached the hybrid PV project, PV CSP, sorry, project, and why, what were the reasons, what were the challenges faced at the early stage of development, and how the project has evolved from the RFP stage, let's say the tender issuance by DEWA, till the signature of the PPA. This was explained in a webinar last year, but everyone who is here in the webinar today, you can ask questions, because I'm not sure if people are following well the details of the project during development and how we reached it or not. So please feel free to ask questions. Today, I'm going to focus more on what happened during the later stage of development, how we have closed the project, what are the key information related to the project, because sometimes we think that we know a project, but we don't have much details, like who are the stakeholders, what is the reality of this project exactly. I'm going to give you an overview of this today, and then also discuss on what happened during 2019, the key milestones that were achieved, and the challenges that were faced up to the end of 2019 and the beginning of 2020.
Okay.
So last year we have shown how we reached the hybrid PV and CSP, and then within Aqua Power how we moved from the first project that we had in PV and the first project that we had in CSP in terms of tariff and competitiveness, and where we were at the time of DEWA phase 4. So now I have a small update, because we have also DEWA phase 5, which has been awarded to Aqua Power. So in terms of projects in the UAE within the same solar park, only in PV we have moved from 5.8 cents per kilowatt hour to 1.69 cents per kilowatt hour, which is more than around 70% of lower tariff. While in the CSP, within only Aqua Power, we have reached more than 60% of lower tariff between the first project that we had in CSP, which is in South Africa, Bokport, and DEWA phase 4 in Dubai. So this project is important for us because since last year, we're talking about the energy transition toward global energy with zero carbon emission. And then this project is a huge project that is really supporting this transition using renewable energy. So now when we go to the details of the project, the project is implemented and owned by a company who is named Noor Energy One, which is a company created here in the UAE, in Dubai. As you may know, here in Dubai, you need to set a company specific to each project because of the requirement of the law here in the UAE. So this is the company who is in reality owning the project. It's an entity owning the project. And the project is part of the fourth phase of Mohammed bin Rashid Solar Park, where we have, before that, the DEWA phase 2 project, which have been awarded to us. And we currently have DEWA phase 5 also. So the project is not just a 700 megawatt project, it is a 700 megawatt CSP project plus the 250 PV project. So it's a total of 950 megawatt. It's not just a 750 megawatt. And the total of 950 megawatt is dispatchable to the grid in Dubai. So one of the key points to retain about this project and the achievement is that it is to note that it's the largest single project as one project using CSP technology, which is unique in it of its kind, having 4 units of CSP unit. So it has also considered 7.3 cents of tariff, so 7.3 cents US dollar per kilowatt hour, which is a world record in terms of CSP. It has not been seen before in other projects. It has also competed with fossil fuel electricity, which is, you know, here in the UAE especially, it is using the country, and Dubai was used to use mainly CCGT and fossil fuel plant. So this project is there to compete purely with the conventional part of power plant here in the UAE. So this project also, we have to know that it's provide 24-hour energy purely from solar energy. So it's solar and thermal storage, using the largest tower in the world. So it has one unit, which is a CSP tower unit of 100 megawatt. And the tallest tower in the world is of 260 meters. In addition to parabolic trough units, which are 3 units there, each of 200 megawatt, totaling 600 megawatt. One of the most important key records that the project has reached is also that it's considered as the largest renewable project in the world in terms of investment, which is huge. It's huge, I mean, compared to the capacity of the project, and given the 24-hour dispatch, the total investment is of $4.3 billion. Okay, the project was, the project was tendered by the government of Dubai, which is DEWA, as part of the Dubai Clean Strategy, to achieve 25% of its energy from renewables by 2030. Here on the right, in the presentation, you would see the concept of CSP that are used here in our project, which is a central tower, 1 unit on the right on the top, and then a parabolic trough below it. So now I would like to give you an overview on the project itself in terms of who are the stakeholders and some other details that you may not know right now. So as we said, the project is owned by Noor Energy One. It is a 700 megawatt and 250 megawatt hybrid. It is an IPP project as a standalone greenfield. The off-taker is DEWA, which is Dubai Electricity and Water Authority in Dubai. The sponsors who are forming actually the project company, which is Noor Energy One, are DEWA as 51%, and then there is Aqua Power and Silk Road Fund. So here in the UAE, also in Dubai, the government need to have the majority, need to be the majority shareholders, where we have here DEWA with 51%. As said before, this project is also part of the same solar park that I will show you later on in a layout, so you can have an idea on how is a solar park distributed. Our scope as developer was to develop, build, own, and operate, so it's a BOO structure. Capacity, as we said, so 950 CSP PV hybrid with 100 megawatt of central tower and 3 units of 200 megawatt parabolic trough with a total thermal storage of 15 hours. So it means that it reaches 24 hours dispatch. Whenever it is required to dispatch, there is always energy to dispatch. And the 250 megawatt AC photovoltaic. The EPC contractor we used in this project, given the importance of the project and the high investment cost of the project in terms of EPC price and then the risks behind it, we needed an EPC contractor that is quite robust technically and also financially. Very important to get also the lenders to approve the EPC contractor. And in this case, we have chosen Shanghai Electric Group company that is currently doing the construction of the project. As O&M contractor, we have Nomac, who is a company owned by Aqua Power and experienced in CSP operation project, who is currently operating, for instance, Noor 1, 2, and 3 in Morocco, CSP project, and also Bokport project in South Africa. In terms of technology providers, as we said, we have 3 units of parabolic trough and 1 unit of central tower, and we have also the PV there. So we needed to have the best technology in terms of, technically and also commercially. So the technology we chose for this project was coming from Bright Source for the city, which is the central tower. So there has been a JV formed by Bright Source and Shanghai Electric for this purpose. And then for the parabolic trough, we have used Abengoa, and then there has been also a JV formed by Abengoa and Shanghai Electric. So when we say a total investment of $4.3 billion, and you can imagine that having a senior debt of $2.4 billion is very challenging. So the developer at the time of development, meaning during 2018, we have worked very, very closely with many lenders, many banks, as you can see here. There are many banks that we have used because we needed to have the debt assured by several banks in order to make sure that we could reach the requirement of the RFP. So as banks here, we can give an example of Standard Chartered. We can also state ICBC, Bank of China, Union National Bank, etc. So in addition to the senior debt, we have used also an EBL, which is an equity bridge loan for our project, and has also used a mezzanine. For the PPA, I'm not sure if people are aware of this, but it is the longest PPA that we have seen in this technology, in CSP, of 35 years. So meaning that we have the construction of each unit, and then we reach a COD, commercial operation date of the project. And from commercial operating date of the project, we have 35 years of PPA to dispatch energy until the end of the term of this PPA, which is quite, which is something very specific to this project, but we have managed to get warranties and get also the lenders and clients comfort on this. So as I was saying, on the solar park, you can see where the project is located. So this is the phase 4 of DEWA, which is a CSP and PV hybrid. Here on that side, we have the solar park is the red. So we have phase 1, which was this small one of 13 megawatt PV, which is operational. It was a small project based on EPC. It's not an IPP. That has been built as a first project, as a pilot project, let's say, in the solar park. Phase 2 is the 200 megawatt, which is also operational now. And it is a project that has been awarded by 2015 to us. And then we have phase 3, which is based on 3 solar fields, so 3 units. Each unit is of, so there is 200, 300, and 300 megawatts each, totaling 800 megawatt PV. And then there is phase 4, which is our project, also the 700 plus 250 megawatt hybrid. And then there is phase 5 and other future projects in that area. So an overview on the technical side. I'm not sure if, I mean, I will repeat things, but you can ask other questions if you would like more, more details, of course. So the site is very well accessible because, you know, we are located in Dubai. It's not very far from the port. There are roads here. The roads conditions are very good. So the accessibility of the project is very good. It is around 70 kilometers from Dubai and 90 kilometers from the port of Jebel Ali, and very well connected to 2 roads from the solar park, so from different accesses. The technology, as we said, so there is a central receiver tower with molten salt, parabolic trough with thermal oil and molten storage, and also the photovoltaic portion. The export capacity is of, as I said before, 950 megawatt net with 250 AC PV, 600 megawatt net of parabolic trough, and 100 megawatt net of central tower. For the solar field, so we have used, as I said before, both Abengoa and Bright Source technologies for the two technologies, the CSP technologies. So we used the Heliostat LH 2.5 by Bright Source for the central tower. And then we used the ST 8.2 collector by Abengoa for all the 3 units. So we have the same technology used in the 3 units, which makes engineering and execution a little bit easier for us. For the PV facilities, we have PV for both internal consumption, which is not allowed to be dispatched, and we have the PV 250, which is allowed to dispatch to the grid. So there are 2 different PV facilities in the project. The one that we talk about in 250 megawatt is the one that is going to dispatch to the grid only. The rest is done for only internal consumption and is not counted in the meter. For the molten salt receiver, we are using CMI technology for the central tower. And for the thermal storage, so we are considering 15 hours for the central tower unit, and then 12.5 hours for each of the parabolic trough unit. The cooling system, we are using air-cooled condenser because, you know, here there is no water, so we have no other choice than using the air-cooled condenser. In interconnection to the grid, we have, so within the project, we have substations, we have several switching stations, and then we have to connect from our switching stations to DEWA substation at 400 kV. So, you know, given that the huge area of the project is around 44 square kilometers, sorry. So it's very far to connect one unit from one side till the other side. So that's why we have several switching stations which are under construction in the project. Advisors. So given the complexity of the project, in terms of, I mean, technically and financially and even contractually also, we have considered different sets of advisors. So there were some advisors related to aqua power, I mean, from our side as a developer. We considered technical, legal, tax, and insurance advisors for the local and for the international ones. And we have also lenders advisors, so which are hired by the lenders. So they use also the same. There are technical, legal, tax, and insurance advisors from the lender side. And then there is also DEWA as off-taker, who has their own advisors in the same way. So there was a huge amount of advisors checking and reviewing the project, making sure that this project is sustainable and is feasible. From the solar resource assessment, you know that as we have our projects there already, which is DEWA phase 2, we had already a meteo station which has been installed at that time there, as in all of the project. And then we could have our GHI from satellite and the ones measured on site. And in addition to that, DEWA has provided also DNI measured on site. So we did a combination of all this in order to have the best assessment. Okay, operational life of the project is of 35 years from initial acceptance of the plant as explained previously. And one of the important points to highlight in this project is that there were the project had some benefit, and two benefits of this is that we had savings in carbon emissions. So we have more than 1.6 million tons per year of saving in carbon emission, and we have also we are planning to power also more than 320,000 residential units in Dubai. So this is the positive side of the project having renewables here in Dubai. Okay, when it comes to the contractual timeline, so many people think that, okay, you have one project, but you start a new project and then you finish the whole project. So from 0 to 950 megawatt. No, this project is having 4 units, different units. So each unit would have its own date of initial acceptance, and then there would be an initial acceptance for the whole project as 950. So the NTP was issued by December 2018, so by the end of the year before. Financial close was reached by March 2019. And then after that, there is each unit having its own initial acceptance. So starting by the parabolic trough, which is the first one, by August 2021. After that, there is the central tower by November 2021. And then the 2 other parabolic trough will follow by April and December 2022. Once all the units are accepted, then there is the planned initial acceptance, which is planned for December 2022. So in case there is a delay in one of the units, then the planned COD is not going to be achieved unless all the units have reached their initial acceptance. So as you can see in this slide, there are some key milestones that we have reached during the development. Just to give you an idea on how the project was developed. So the tender was issued in 2017, in January 2017. The bids were submitted based on 2 towers of 100 megawatt each as base proposal in June 2017, where the bidders had the right to submit a proposal which is alternative. So we could change the technology or bring something which is providing a better LCOE to the client with a certain value, of course, as alternative proposal. And this is what has been accepted by our client. So we have worked with our client and we have been awarded not the base proposal, but the alternative proposal. After that, there was PPA signature was happening before the ceremony. Then we had the ceremony with His Highness in March 2018. We have signed after that the EPC contract by April 2018 in Shanghai. You can see also here that the project has played a very important political, politically was very important. So the head of state in the UAE and China have met, and then they have highlighted this project and discussed it during the meeting. There was also in Spain, the head of state also have met between Spain and China, and they have discussed also this project. So from a political perspective is very important and is bringing a lot of advantage in terms of collaboration between the 3 countries. After that, so we have issued an NTP by, as we said before, December 2018. And during all that time, there is a construction until initial acceptance, and then there will be a final acceptance after 3 years from that. Now we can go to the contractual structure. So we always hear, okay, this is a project of DEWA or Aqua Power, but we don't know who is really behind that. So here it would give you maybe an idea on how it is structured in detail. So DEWA is the off-taker, as we said. There is Aqua Power and DEWA who created each a company called a hold company. So within the DEWA hold company, it owns 51%, as we said. And for Aqua Power hold company, there is Aqua Power and also Silk Road Fund forming a company together, each of them having 51% and 49% within this company, and entering into a shareholder agreement between DEWA and Aqua Power Holdco to form the project company. So the project company is Nor Energy One, which is formed by both hold companies, and has signed a PPA with DEWA directly as an off-taker. In the meantime, it's the project company who enters into the financing document with all the lenders, with a big number of lenders in this project, given the high amount of the investment. And it enters also in the meantime with the EPC contractor Shanghai Electric, where Shanghai Electric itself has a subcontractors. In this case, one of the key subcontractors are the technology providers. So there is the Abengoa side and then on the parabolic trough, and then there is also Bright Source on the central tower. The project company also enters into an O&M contract, which is with NOMAC. Within the project company, so the RFP imposes that each project company has an owner engineers in order to verify and review all the works related to the EPC part. So in our case here, Nor Energy One has appointed Worley person to be the owner's engineer, who is currently actually reviewing all the project documents in terms of EPC. Okay, so for the key achievements during 2019 up to end 2019, or let's say January 2020. So there were, from the financial side, there is a financial close which was achieved in the first quarter of 2019 that we explained before. So it was a little bit challenging because of the complexity of the project, not only the amount required for the project to be loaned from the lenders, but also the contractual structure, the technologies that have been used, the mix between the technologies, the risk allocation in each unit and how it is distributed contractually. So it was challenging in terms of achievements to get it signed. Important point that we have achieved during 2019 is the CBI Climate Bond Certificate, which is the first in the GCC and the Middle East for a project which is a project finance, renewable project finance project. So we are very proud and very happy for having it achieved. That means that that in the future, if we want to have any restructuring of the financing or any refinancing in our case, it would attract much more lenders with more competitiveness, of course, given that the project has been certified already by CBI for the climate bond. From the execution side, the first key the key milestone that have been achieved in 2019 is that the central tower, I mean the concrete tower, the civil construction part, has been achieved, and that was a very important point. So currently we are erecting the MSR on the lower, and then the lifting is going to start by May 2020. So that's going to be, I mean, another very important milestone to be achieved in 2020. For the solar field, It is ongoing as per schedule. So it has started ahead of time because we had the engineering that started earlier. So we could do many works which were ahead of time. We have completed the procurement of major equipment. So that is that is a very critical point, which was very challenging at the beginning, because you know, when you have one project only, one unit only of 100 or 200 megawatt CSP, it's not an issue to achieve the procurement of major equipment and issue the POs. But when you have 4 units with different technologies, where you would need a large amount of heat exchangers, of many turbines, of transformers, of main pumps, of molten salt. And considering that we are talking about a 24-hour dispatch, meaning that for example, for the thermal storage, you would need a lot of much more quantity of equipment than the normal CSP project of 2, 3, or 4 hours of storage, then that was very, very challenging. And we are very happy that we have achieved that in 2019. So for the parabolic trough, the map has been completed. So the manufacturing facility for the trough is completed, and then we have started the construction and erection on site. I will show you later on a photo. And we have also reached 3,200 employees on site in total as of now. I mean, not as of now, but as of the beginning of 2020. So now it must be more. Within these 3,200 employees, we have reached more than 4.2 million safe man hours, which is a key point in terms of safety in the project. Okay, when it comes to challenges faced during the construction, so after financial close, you know that this is a unique project for us and for our EPC contractor. So adaptation to the site was a challenge at the beginning, because so considering that there are dunes, I'm not sure if you have an idea on how the site is, but it's almost full of dunes. And when we say dunes, it's not just 1 or 2 meter dunes, it's around like 30 meter dunes. So it was very challenging for the beginning to start working on the site leveling. So which strategy we have to use, which subcontractors are familiar with this. So we have to take some subcontractors, present them to the EPC contractor in order to work on the dunes leveling, and using also the cheapest way and the best effective way in order to get rid of the dunes. Because, you know, for CSP is not like PV. For CSP, you need to be, especially for the parabolic trough, you need to have a very flat area with a very small angle. So that was one of the challenges. The weather conditions, it was also the first time for our EPC to work here in Dubai. So it was a little bit slow at the beginning, because they had to get used to the weather conditions, when they can work, and when it was summer, when it was Ramadan here. So it was a bit of a challenge. And then also the local requirements. So here, given again that it's the first time for our EPC contractor to have a project here in the UAE and in Dubai. So the local requirements, like for instance, all the permits, all or the approvals that are required for the project, what is allowed to be done, what to do, who to contact, it was a bit of a challenge at the beginning. The second point is related to coordination. I mean, you know, the project is has several units, has several technology providers, and has many subcontractors and suppliers of equipment. So coordination between all of them was challenging, because we had and our EPC also had to understand to whom to talk, when, who is approving what. We have also different engineering companies, so they were using, for instance, Empresarios Agrupados for the engineering review, and then there is, in the meantime, our people from the project company, from Nur Energy One. There are also the owner engineer to be taken in consideration to review and approve. So all that has taken a little bit of a learning curve for first, not only engineering, but also for the execution during the first months of the project. So we had also to see with the EPC contractor, and especially, I mean, the EPC contractor had to find out who are the best subcontractors who need to work on this project. So we needed some subcontractors which are experienced, not all in the technology. So there were some subcontractors, it was important to get them experience in the UAE, in Dubai, in terms of, for example, of earthworks, for example. And there are some other subcontractors that had to be experienced in the technology itself. So those who are doing the erection and other aspects of the project. So that was a little bit challenging at the beginning. But once we settled on the learning curve, then it was easier to go smoothly after that and just work on the execution of the project. It is to note also that the engineering coordination with various parties, considering that the EPC is Chinese, the project company is from Dubai, the technology providers are from Spain or UK, and there are other subcontractors and key parties in other locations. So coordinating between all of them, it was at the beginning a little bit hard, but then it went smoothly, same as for other items. And the last point, which was very challenging also, is the amount, as I said before. If we have a big number of equipment to be ordered, then maybe availability in the market is not enough, or the market is not used to provide such availability of equipment. So we had to work very hard at the beginning together with EPC contractors to ensure that manufacturing is going as per plan and issue the POs on time, especially for the key equipment which are critical to the project and which are running. So I have, before going to that, maybe I would just add that from the contractual side, we had, I mean, the complexity of a project had to consider also that it's not just one project saying that, okay, it has a PPA, it has an EPC contract, and it has an O&M contract, and then it has just some subcontractors, and that's all. No, the project had to take in consideration that we needed a robust EPC. The EPC had to be financially and technically capable of executing the project. The project is a key project for us and for the government of Dubai also, so there is no way that we could mess around it. It's a very costly project, so it's a very high investment project. So the risk allocation is not like in a small project, where if you lose, for example, a portion of it, it's not an issue, it's not a problem. At the end, it's not much money. Here we are talking about $4.3 billion, where any issue in the project would cost us a lot of money and would cost the EPC also a lot of money. So there have been many bonds that have been structured with the EPC contractor at different levels during the development of the project, during the execution of the project, and also during the operation, the first 3 years of operation of the project, which is, although it is done by NOMAC, the EPC contractor had to provide some bonds in order to ensure the performance of the project during 3 years. There were some mechanisms worked out in the contractual part, in terms of plant unit performance, termination, etc. There have been also the use of different technology providers, and also the use of PV, which was PV either for internal consumption, PV for dispatch, and there was also at which level we had to put the PV for the dispatch metered, and then how to separate the PV for the internal consumptions without putting it on the meter, etc. So it's not a simple project that we talk about like one thing, but no, we have to think about all these aspects in order to structure and make the project acceptable to us, acceptable to DEWA as off-taker, and also acceptable to the lenders, especially because the amount of senior debt that we got from the lenders of $2.4 billion was a very large amount, which the lenders are not used to provide. So as photos, I mean, you can see here the city tower, which has been finished. I think the concrete part is of around 220 or 22 meters, I think, for the concrete part. And then after that, there would be the MSR. It is here. Sorry, the photo is a little bit old, but this is what we have for now. So the MSR would be lifted up as we said, and planned to be lifted by May 2020. On the right, there is the city power block, just to give you an idea of how it is. And then below we have the parabolic trough solar field and the parabolic trough power block. So what you see here is mainly the molten salt tanks. Here is a photo for the central unit with the tower and also the heliostat. And here is one for the PT1 unit. So PT2 and PT3, when I say PT, it means the parabolic trough. So the two other units are not yet, I mean, we did not start the solar field yet. So for now, the priority is for the central tower and the parabolic trough one. As I said before, when the concrete tower of the central tower ahead of schedule, and the project has also won the power deal of the year during the PFI ceremony for the Middle East and Africa. Yeah, and that was all. So thank you very much. I think I talked a lot.
Thank you very much, Miriam. Yeah, you did, but you know what? I didn't stop you because it was very interesting. And I actually, so that you know, while you were talking, I said to people, we are going to stay longer if we need to. We're just going to hear both presentations because I think this is very interesting. So thank you very much for that. Can you please stop sharing at the top of your screen? And I'm going to ask Manuel to share his screen. We had some technology issues at the beginning. I hope we don't have them now, but if we do, we'll deal with them then. Thank you very much, Miriam. You've gone into a lot of detail. It's been really interesting. There are some questions, and I'm going to extend the panel, you know, so that Manuel can do his presentation, but we're unlikely to have time for questions and answers. So I would ask you, if you don't mind, to go into the Q&A and respond to them like in writing.
Yeah, sure, I'll do that.
Thank you very much. Thank you.
Welcome.
Manuel, we can see your screen and you're good to go.
Okay.
Take your time, as you know, as we said, we already advised everyone will take whatever time we need. Thank you.
I will try to be shorter. I was expected to do this presentation in 15 minutes, so I hope to be brief. And some information that I wanted to share was very well explained by Marian, so it will be easier for me because I will save some time with so wonderful presentation from my colleague. So with these slides, I would like to introduce the power plant that we are constructing I will do a very brief summary in terms of design, because I have told Marian also did this explanation, and I will give an update of the status of the project in terms of the parabolic trough construction and design. In this slide, you can see the location of the project is close to Dubai, that it was already mentioned. The plan is comprised by 3 parabolic trough plants and 1 central receiver plant, all of them CSP technology, and also a PV plant. The EPC constructor is Shanghai Electric, and the scope of Abengoa in this project is limited as technology provider and parabolic trough solar field subcontractor. In this sense, I would like to share with you that the main difficulty that we are facing in this project is the coordination of all the parties. Like explained by Marin, there are many players in this huge project, and it's not easy to coordinate all this. It is, as lesson learned, I can say that in terms of engineering coordination, it is really time consuming to have several companies worldwide doing this project engineering. It is difficult to homogenize the design conditions of the project if many project companies are working together doing a connected engineering, but working very far one from the others, and different cultures even between the companies. And it is also very difficult to coordinate and to clarify the battery limits between one company and the other company. That is the main message that I can throw to you today in terms of coordination. The plant concept. You can see in the screen the main components of the plant. We have a central receiver shower plant. We have 3 PT CSP plants of 200 megawatts is one, and we have PV plants. One of the questions of one participant was if the thermal storage system was distributed or centralized. Is it distributed? There are different thermal storage systems for each CSP plants. Indeed, the parabolic trough plants are 3 identical and repeated power plants with different power blocks that, like we will see in the plot in some slides ahead. In the case of the PV plants, there are like 2 kinds of PV plants. There is one huge PV plant just for electricity production that is designed just to produce electricity, to increase the production from the CSP plants, limited obviously to the sunny hours. That is when the PV plant is able to produce, is 250 megawatts in that case. But there are also 4 additional auxiliary PV plants that are designed and are going to operate to cover the parasitics of each of the CSP plants. And the main driver to go to PV plants, as it is obvious for everyone, is the low cost of this technology right now, and it is a good way to lower the LCOE of the solar energy. Another important characteristic that Abengoa is in this project providing is the performance model tool. It's essential in a project of this size to have a performance model tool, because it provides benefits in all the phases of the project. In the tendering project, it is the right tool to estimate production and to have accurate figures to design and to finance the project in a good way. Then during the engineering phase, it is really essential to have an hourly, even lower step time production and parameters estimation to have a good design of the equipment and a good specification of all the plant. That is very important also. And then in the last phase during the operation, it is also very important to check that the plant is operating right, it is expected. And it is also very important to have a production forecast of the power plant. That this is very, very important for an utility in the end. Performer cubes. I will be very, very brief because I think it is more or less known the performance of the thermal storage in a CSP plant. In this project, the design of the CSP plants and all the solar park was done with the guidelines of DEWA. They have some requirements. I will try to cover all these requirements, and you can see in the pictures, in these two pictures, the winter expected performance curve and summer performance curve. The black line is the gross electric power. You can see that in winter there are no production midday between 6 and 16 hours of the day. The CSP plant is off, but it's different in case of summer. In summer, the production is a base load production 24 hours for all the summer. So this is able to do with CSP plants with thermal storage. It's not possible to do with PV plants. That is very important. That is the main capability of the thermal storage systems, and we have taken that advantage from the CSP and thermal storage in this plant to cover the needs of the utility company. This is the performance curves of the PT plants. Is not included in the central receiver production. In where we are in this moment about performance in the project, we are right now checking all the information from the vendors and the detail engineering, because in the tendering process, Abengoa performed and developed the software with estimated information from other projects and with the long experience that Abengoa have in this sector. But right now we need to implement real information from vendors, real information from detail engineering, to update the figures and the values that the plan is going to produce in the coming years. That it is really important. We have a contract with very serious guarantees in terms of production and performance, and to check and verify that every purchase and engineering is going like expected is very, very important. And we are right now in that point in terms of performance. This is the solar field plot of the solar park. I wanted to share with you this plot just to see the magnitude of this project. There are 3 PT plants. PT1 is the one top left, and PT2 and PT3 are bottom of the plot, and then the central receiver is the circle one. Just to show you this magnitude, I draw a small football ground top left in the PT1. You can see that is the real size of approximately a football ground. And also you can see the footprint of a 50 megawatt PT plant with no storage. So in this project we're going to construct like 1,000 football ground area full of mirrors just for PT plants. We are going to construct like 19 50 megawatts PT plants like others in other locations. So this is really challenging. Other magnitudes. In which status of the project is the PT are the PT plants right now? The engineering is closed for PT1, is closed for, or the basic engineering for the 3 units is almost mostly completed because it's identical, but the detail engineering is finished for PT1, and we are working right now with the others. Where we are in procurement phase. The procurement for Abengoa and for solar field PT is also completed. We closed all the purchases in terms of structure, mirrors, receiver tubes, and control and so on for this project for all the 3 units, and it was really challenging to close some of these purchases because the contracts were really huge. We have to analyze the production capacity of suppliers to be sure that they were going to comply with the delivery terms, with all the units that we need for this project. We are going to construct this in 26 months, so it's not an easy task to comply with this. What else? In terms of logistics, it's really important to analyze during the procurement phase how we are going to transport all this material, because we are talking of more than 8 million square meters of mirrors. We're expecting to produce more than 150,000 tons of steel structure, in spite of having a very optimized collector for this project with the minimum steel needed for the requirements of the project. We are going to have more than 150,000 tons. Another example, receiver tubes. We are going to install more than 250,000 units of receiver tubes. The capacity production of the main manufacturing in the world is going to be only for this project for the next 26 months. It's very important to have this in mind during the construction and during the engineering phase. For example, a learning lesson that we have also taken is the transport time. That you can see a picture of some tractors moving the collectors in the solar field. You can imagine that from the workshop to the extreme of the PT plant, it might be like 6 kilometers. 6 kilometers moving a collector with a tractor is a long time, and it is some feature that it should be taken into account during scheduling the project. What else? In terms of manufacturing, assembly collectors, and warehouse, what are we facing right now? Like Marian told, the assembly of collectors started end of last summer. We're right now mounting the collector for PT1. The advance of the project is good. We have completed the learning cube of the assembly. This is really important for a project like this, to have into account, to take into account the learning curve of the workforce, because we have contracted local people who is unskilled in this kind of manufacturing. They are also obviously supported by Abengoa staff with long experience, but the most of the personnel is unskilled people. More than 800 people are working right now in this huge factory, 20 hours per day, 6 days per week. It's needed to assembly sorry, more than 200 collectors per month to comply with the schedule of the project. It is really challenging, like you can imagine. Take a look to the picture of the warehouse. You can see the stock that we need to have all this factory in production. It is also very important in this warehouse the quality control, the incoming registration, the traceability of the materials, the logistics needed to unload all these trucks. Take a look to the figures. We are receiving like 500 trucks per month just for steel, more than close to 200 containers per month for mirrors, and an average with other supplies like hydraulic units or receiver tubes or other components. We need to get in plan an average of 30 trucks every day. If you make some numbers, it is really challenging to do this, and very good infrastructure and personnel, qualified people to do this is essential to comply with the project requirements. In terms of engineering, what have we done in the for this project in engineering? We have performed a real 3D model of the PT plant and the HTF system, which is the scope of my company. This 3D model have real dimension, real information of all the equipment for this plant. This is very important to avoid interference during construction, to avoid any problem in all the construction, also operation phase, to have a real modeling of the components in terms of mechanical, civil, wiring, instrumentation, and all the disciplines are integrated into a model. This model covers the solar field, covers the power block, and all the piping, and it's essential to work like this. And it is also very important to do like this to coordinate all the parties. Like we say at the beginning, if we are working together, some companies on this, we need to have a common tool to integrate the design and to be sure that we are all working on the same page. Some figures about the project. We are designing pipes up to 1.6 meters diameter. Take a look to the picture. There are some pipes higher than a man. The kilometers, we have 200 kilometers of high temperature oil piping in the solar field. We have more than 3,000 kilometers of wiring, and the inventory of HTF is over 55,000 tons. The production of the main manufacturers of oil in the world is almost in this project for the next months. To finish, I would like to share with you a picture of the overflow tank. An overflow tank is a component of the HTF system. We have 9 units like this for every PT project. So there will be like 27 units like this one. This is just to show you the challenge that we're facing during design and construction. Imagine the difficulty to design in terms of mechanical and civil issues for this kind of equipment. Also, the difficulties in terms of logistics to transport a 50 meters tank. In the bottom of the slide, you can see an aircraft. This is a real aircraft. It is an Airbus A320 inside the tank. So this tank is larger than an aircraft. Imagine the kind of project that we are in front of us. That is my message today. That is really challenging to be here. It is an honor, honestly, to work for this kind of project, and I'm glad to be part of this huge project, and that's what I can share with you. The challenge that we are in front of us. Unfortunately, it is going, and it is successfully complying with all the needs of the project from the Abengoa scope. Thank you, all of you.
Thank you very much, Manuel. Okay, so Miriam and I have been doing the best we could to respond to as many questions as possible. Can you take the presentation off? By the way, awesome graphics, you know, to see the tube next to the plane is amazing. And also to see the sheer size of that project. I mean, compared to the normal 50 megawatts Solnova. So we are obviously cannot get to all of the questions. Apologies to those that we haven't answered. I mean, I tried and answered some of the questions I knew the answers to as well, you know, just to hurry it along. But I just want to ask the question that Imram, Mian Imram is asking now, and that someone else asked, coronavirus and this project. And after that, we'll just, you know, say goodbye. But is this having any effect now? Can you tell already whether this may have any effect in the mid or longer term? You know, just to the two of you. Miriam, do you want to start?
Yeah, so I think for us, we have to take in consideration that our EPC is Chinese, but we were very lucky that by the time, I mean, what we have seen in the world is that the virus has spread after, after the Chinese New Year, mainly in other countries. So we were very lucky that all our EPC and EE subcontractors, they were working during that time, so they did not go home for the Chinese New Year. So for now, we have 0 cases of coronavirus at our projects, which is a very good, very good for us. So it's not impacting at all the execution of the projects in terms of people available to do the work. From the other side, it is a challenge now to be managed carefully. We don't know, I mean, what's happening and what is going to happen in the next month. We don't know how long time is gonna, this is going to be continuing. So we don't know whether the suppliers would have any impact or not in the near future, let's say. For now, we don't have a confirmation, for example, to say we are having a delay. No, we know that there are some companies, contractors, or manufacturers or things like that, that they have stopped the work or partially stopped the work, but still the project is on time. There is no delay for now. But I mean, we don't know if this is going to stay for 1 month or for 1 year. It depends on how long time it's going to take, basically.
Yeah, I suppose no one really knows how long we're going to be indoors either.
Yes.
So
yes,
it's
and
hard
I think
to tell.
everyone is just trying to think of solutions. But I mean, to be honest, there is no solution for now.
No,
I mean, we're all we're all in the same. We're all having the same issue. We don't know what's going on. Our project, the good thing is that is a very long project, so it's not like a project of, I don't know, of 6 months PV, for example, or 9 months PV, which would be really affected if you are saying that you have 2 months delay in the delivery of whatever equipment. Here we are talking about 32 months. So we will see what happened maybe in the next 3 months or 6 months, where we would have a better idea on how to face it.
Excellent. Thank you very much, Miriam. And Manuel, do you have anything to add in terms of the equipment side?
From the engineering, I can say that we have up to now no impact by this, because engineering team is located in Seville. We are not in the headquarters of Abengoa. We are at home, but we can go on with our work. So we are working good, and construction team on site is also working from the suppliers. We have up to now we have no impact, because it's a bit soon, but we have some Chinese supplies and in their deliveries. So we are glad to say that up to now we are in the same situation, and hope to be this way from the coming months.
So thank you very much, both of you. You know, we've run a little bit out of time, but I think this was well worth it. And thank you very much for everyone also in the audience that stayed there. So Miriam, thank you very much. Manuel, thank you very much. And I will see you next time. Thank you. Bye.
Thank you. Bye-bye.